Welcome to lecture for Research Methods, Dr. Fiala. Be talking today about going beyond a simple experiment, even beyond doing multiple levels of an independent variable in experiment, and looking at factorial designs. So, starting off, what is a factor? Well, when you're talking about an experiment, a factor is an independent variable. If you're talking about non-experimental designs, you could have applied a lot of the things we're talking about here today to those as well in terms of other types of factorial designs, non-experimental factorial designs. And in this case, a factor is any kind of categorical variable um, which you could use to create groups of participants where you're interested in differences in some variable, typically the dependent variable, differences in that variable according to what group you're in. So it can also be thought of as a grouping variable. Right? So in a quasi-experimental study, it might be the quasi-independent variable. In a correlational study, it might be something you call a subject variable. Like if you're looking at, oh gee, I wonder if men and women differ on this thing. Okay, well that's something you can't manipulate. So it's not really truly an independent variable, but it's a subject variable, and it could be a factor in a factorial design. Okay. So we know what a factor is. It's a variable, a categorical variable at the minimum. And a factorial design is any design that involves more than one factor. So more than one grouping variable, or an experiment, a true experiment, more than one independent variable. So these factors can be between subjects factors or within subjects factors. Now, a between subjects factor is one in which each participant can only have one value for the factor. They can only be in one level of the variable. So if it were a subject variable like biological sex, you couldn't be both a man and a woman. You can only be one of those. You can only be in one group. That's a between subjects factor. If you're doing an experiment where you're giving some people a drug and other people a placebo, and you can only get the drug or the placebo, you can't get both, okay, that's also a between subjects factor. Now, a within subjects factor is one where participants receive all levels of the factor, all levels of the variable. So the most common one would be time, if you're doing any kind of pre-post study, or time 1, time 2, time 3. Okay, all participants are getting measured at time 1. They're all getting measured at time 2. They're all getting measured at time 3. So that would be a within subjects factor. And maybe you wanted to do an experiment where you had the drug and the placebo, and first you gave participants the drug and you measured them on some dependent variable. Then you waited a month and you gave them the placebo. Again, they don't know which is which, but then you gave them the placebo. Again, measure those same people on the dependent variable. Okay, if they got both levels, now that's a within subjects factor. Okay. And we'll talk more about between subjects and within subjects factors the next lecture. So for now, we'll focus mainly on between subjects factors, because it gets a little more complicated once we move to adding within subjects factors or combining between and within subjects factors within one design. A little bit about the nomenclature of factorial designs. There's a way that if you're reading articles, you'll see it written about, and if you're writing something about a factorial design, you'll need to use the same nomenclature. And using the nomenclature, you can indicate with a small amount of words and characters the number of factors you're looking at and the number of levels per factor. So the basic format is this is a blank by x is the by blank factorial design, where in the blank goes some number, right? So if you're looking at the first one, a 2 by 3 factorial design, okay, well, there's two numbers there, a 2 and a 3. So there are two factors, two variables. The first variable has two levels, so maybe that could be biological sex, men and women, and then the second variable has three levels. Maybe you're showing men and women different types of movies, horrors, horror movies, comedies, and dramas. Okay, so 3 different levels of that variable, 2 levels of the other. So you know how many factors there are and how many levels of the factor. Okay, and the next one, a 3 by 2 by 2 design. So now we have 3 factors. The first one having 3 levels, second one 2, third one 3 levels. The last one, a 1 by 2 by 3. Notice anything maybe wrong with that one? Hopefully you'll never see a published paper where they wrote down that they did a 1 by 2 by 3 or a 1 by 2 or a 1 by 3 or anything that has a 1 in it. And why not? Well, you can't have one level to a factor, right? Because a factor, again, is a variable, and a variable, to be a variable, has to vary. And if there's only one level of it, it doesn't vary. It's a constant, right? So if I want to look at the effects of or differences between men and women, so for biological sex, I'm going to have one level, men. Okay, well, you're not comparing it to anybody. You say, well, I'm just doing my study just on men. Okay, then you're not looking at differences in biological sex if you only have one level of that variable. So if you ever see a 1, you ever write a 1 when describing a factorial design, something has gone wrong. One other quick little thing. If you have a fully between subjects design where all the factors are between subjects factors, so look back at that 2 by 3 for a second. So that 2, it's either men or women, and then 3, we said 3 different types of movies: horror movies, comedic movies, and dramas. So participants are either going to see a horror film, or they're going to see a comedy, or they're going to see a drama. They're not going to see all 3. Right? And you're going to have men seeing one of those 3, you know, a group of men seeing one of those types of movies, another group seeing another, yada yada yada. So my point is, if it's between subject design, you're going to have lots of groups. How do you figure out how many groups you need? You just do the math. And that 2 by 3, you can think of it as 2 times 3. Well, at 2 times 3, that would be 6 groups. So if you did a fully between subjects design, you would need 6 different groups of participants to do that design. Not that big at all. Move on to the next one, a 3 by 2 by 2. So 3 times 2 is 6, times 2 is 12. 12 different groups. So 12 different groups of participants doing slightly different things, which still you may think, oh, that's not that big a deal, until I start telling you, well, you do have to keep in mind that to have enough statistical power to find an effect, you've got to have a certain number of people per group or per cell. It's kind of the language we use sometimes. It really depends on what you're looking at, but as a general rule, you probably want at least 20 people in a cell. Again, depending on what you're looking at. So 20 people in a cell with, what do we say, 12 cells, that's a lot of participants to gather. Okay? But again, to know how many groups you need, you can just multiply out the factors, and to know how many participants you need, then you can figure number of participants per cell, and then multiply that by the factor values. Okay, a quick little example of a 2 by 2 factorial design. So this is a table looking at maybe if somebody wanted to do an experiment looking at the difference between face-to-face therapy and online therapy. So there's 2 different therapy modalities. So one factor, one of the 2's, would be therapy modality. And it has 2 levels, face-to-face and online. So the variable isn't face-to-face, the variable isn't online. The variable, the factor, is therapy modality, and it has 2 levels. And then looking at, okay, what's the effectiveness of each modality, and then you want to know, well, I want to know how effective is it, but I'm interested in 2 particular groups: people that present with social phobia and people that present with specific phobia. So again, our other factor would be presenting problem, which also has 2 levels, either social phobia or specific phobia. And so whenever you see a table like this, it's set up to where the numbers inside the cells, and those little boxes are called cells, represent the dependent variable. In this case, the dependent variable is symptom severity after treatment. Right? So not a pre-test, post-test, just got these people together, got some people with social phobia, gave some face-to-face therapy and gave others online therapy, got another group of people with specific phobia, assigned half to receive face-to-face and the other half received online, and here's the pattern of results you get. Okay. So before, I know you're probably wondering, well, geez, how do I make sense of this? Before we jump to how to interpret factorial designs, let's take a look at why we use them at all in the first place. So you're getting more bang for your buck in a way, right? Because in some ways you're getting to do 2 or more potentially studies at once, right? So again, imagine you're interested in the effects of therapist experience, lots of experience, new versus neophyte therapists on client outcomes. But you're also interested in the effects of therapist gender on client outcomes. So are male therapists, female therapists, do they have different outcomes with clients? So you could do 2 separate simple experiments and look at both of those questions. Or you could combine them into one factorial experiment. So you're getting moving along the gaining of knowledge much more quickly, and there's the added advantage that you can see how or if these 2 variables interact. And that's really probably the most interesting thing about factorial designs, is the possibility of looking at the interaction between 2 factors. Okay. And we'll talk more about what interactions are in a bit. But in terms of general uses, for external validity, this is where sometimes you're looking for a non-significant interaction. I'll give you an example. Maybe you want to show that the effect of some variable is the same for different groups of people. So you've got some treatment that you want to show is effective, and so you have a treatment group and a control group, right? So one factor is treatment, 2 levels, yes you get the therapy, no you don't. And then you look at these subject variables of maybe culture or ethnicity, sex, education, religion, whatever, pick one. And so you're dividing people into groups based on some subject variable. And here you're hoping that the effect of the treatment, that people that get your treatment have better outcomes than those that don't. And that this is true no matter what ethnicity you are, if that's your other subject variable, no matter what biological sex you are, if that's your other factor, so that those 2 variables don't interact. So this one variable's effect is true regardless of level of the other variable. Okay. I had another example here, looking at what's this? You want to show your new therapy is better than an older version, but some folks say it won't be good for older adults. So you put age in as another factor, hoping to show that your therapy is better than this other one for all groups. So for young adults, adults, and older adults. Okay, so a non-significant interaction term. It can also be used to rule out alternative explanations. People might say, oh yeah, you found the effect of this on the steeping variable, but it could have been this other factor. Well, if you examine that other factor, you can rule that out. So let's say maybe you're doing a study looking at how putting people in different size groups has a different impact on social loafing. So you put them in a group with 2 other people, with 4 other people, or 10 other people. And these others are all Confederates, right? And you just want to see how hard is this person going to work? How much are they going to social loaf or take it easy when in this group? And you're not going to do this yourself. Of course, you're going to have your grad students running the study. And let's say you have 3 grad assistants who are running participants for you. And people might say, oh yeah, well some of these, there might be some differences going on because of these particular grad students. One was different than the other. Well, you can include experimenter as one of the factors to make sure that the effects of group size, which is what you're interested in, are the same across all levels of experimenter. Right? You can determine statistically if there was some experimenter effect where one grad assistant treated participants differently than others, and you can rule that out. Looking for exceptions to some rule, right? So sometimes maybe in the literature there's some established effect. Okay, we know this does this. This has this effect. And you want to replicate it, but you think, you know what? Yeah, that's true, but it's not true for this group, or it's not true when this happens. So maybe you're looking at a group therapy procedure that's shown to be effective, and you're going to measure client outcomes pre-post. So one of your factors is time, and so generally, if you're just doing a regular within subjects experiment to look at does this group therapy work, you would measure the participants, administer the group therapy, measure them again, and you're going to see some change, right? And if it works great. But you're saying, okay, well, it's not going to work for everybody. It's because it won't work for kids who have a history of aggression, because other research has shown that when you put aggressive kids together, they tend to become more aggressive. Right? So you have this other factor of history of aggression, some that do, some that don't. And so here you're looking for a significant interaction effect to say, okay, yeah, this therapy works, but not for everybody, not for this group. Okay. You can also use it to identify essential elements of some effect. Right, so whenever there's some complex or maybe multi-component process that's thought to have an effect on a dependent variable, you can examine which parts of the process are most essential for the effect. So looking at EMDR, right, eye movement desensitization and reprocessing, where people are talking about a traumatic experience while the therapist is moving some object, their hand, something, back and forth across the person's midline, right? Having the person follow their hand, inducing bilateral eye movements, right? So that's EMDR. So maybe you think, okay, well, they're doing this exposure to trauma and they're doing this bilateral eye movements. Do you need both? Right? And so you could do a factorial study to find that out, where if you find that exposure trauma, having people talk about the traumatic event, when they do that, they get better regardless of whether or not they do bilateral eye movements. Okay, well, that's an important finding. If not, you find, okay, yeah, they only get better when you have both. When both you're exposing the trauma and you're doing the bilateral eye movement. Okay, well, that's also would be important to know. Okay, last, Factorial Design is very helpful for dealing with problems caused by within subjects designs, but that's something we're going to save for the next lecture. Okay, on to interpreting the results. So whenever you have a factorial design, you're going to have some main effects to interpret, right? And a main effect is the effect of one factor. So logically, you're going to have potentially as many main effects as you have factors. So if you have a 2x3 design, you have two main effects to look at because there's two factors. If you have a 3x2x4 design, well, that's three factors, so three potential main effects. Okay, so the main effect is the effect of just one of those factors. And a couple ways to think about it. It's the effect of one factor averaged across all levels of the other factor or factors. Or another way to say it is it's the effect of one factor ignoring the other factors. Or one more way, just in case that didn't make sense yet, it's the effect of one factor, the effect of one variable, independent of the effects of the other factors. And as I already said, the number of potential main effects is equal to the number of factors you start with. And again, those are potential main effects. Whether or not you have a main effect depends on if it's a statistically significant main effect, right? Which these days we just let the computers tell us if we have those or not. Okay. So with let's see, what we talked about. If you're doing the EMDR type study, right, where you have exposure, not exposure to the trauma, not exposure to trauma, bilateral eye movement, not bilateral eye movement, you probably expect a main effect of exposure to trauma, where people, regardless of whether or not they get exposed to bilateral eye movement, if you expose them to a traumatic event, have them process it, they're going to have some symptom reduction. There should be a main effect of that. The eye movement thing, if it really does anything, there should be a main effect of that as well. So you could have, if you have a two-factor study, you could have one significant main effect, two significant main effects, or none. Interesting thing is, though, no matter how many main effects you have that are significant, if you have any that are significant, they may be qualified by a significant interaction. And what this means is that the main effects aren't very interesting if the interaction term is significant. And we'll talk more about exactly what that means in just a sec. Okay, so interactions. You can have two-way, three-way, four-way, five-way, yada yada, but there's a point of diminishing return. So a two-way interaction is when two factors interact. Three-way is obviously when three interact, on and on. And now we'll talk mostly about two-way interactions, and we could talk about interpreting three-way interactions. Once you try to interpret four-way interactions, it gets very, very complicated. You're in this kind of this quadratic realm where you need another dimension of communication to be able to talk about what's going on. So we'll limit our discussion primarily to two-way interactions, and those are the ones that you're most commonly going to see. And when you see a three-way interaction, usually they break it down. So, okay, there's a three-way interaction, and now we're going to break it apart, right? So they're going to pick one factor that maybe has two levels, level A and level B, and say, okay, for level A, there's this two-way interaction going on here. For level B, there's the two-way interaction between the remaining variables is different. Okay, but again, we're going to focus mainly on the two-way interactions. Okay, so for a two-way interaction, what is it? Well, it happens when the effects of one factor on the dependent variable differ across levels of the other factor. So the effect of one variable, what it's doing to the dependent variable, isn't always the same. For one group it happens one way, for another group it happens a different way. And those groups I'm talking about are created by levels of the other factor. Right? So the effects of one factor differ across levels of the other factor. Give us a more concrete example to look at here. So imagine a study, 2x2 design, where kids are going to be shown a movie clip, either one that's kind of emotionally arousing in nature or emotionally neutral. And then they're going to have a peer model who's a Confederate watching the movie with them. And this peer Confederate is either going to eat some snacks, a certain amount of snacks, 10 chocolate peanuts, or not eat anything. And what we're looking at, the dependent variable here, is how much food does the participant eat? Right? So the idea being, okay, are they going to be influenced by what the peer does? So are they going to eat when the peer eats and not eat when the peer doesn't eat? And is that effect going to be the same or different depending on what type of movie they watch, if it's emotional in nature or neutral in nature? Okay. So look down at a little table there where you see on the left movie clip and at the top Confederate behavior. And we've got some data, hypothetical data plugged in here. Excuse me. So when kids were watching an emotional movie and the Confederate was eating, the participants ate 8 peanuts. Okay, that's that top left cell. We go over to the right from there. So still looking at emotional movies, but now when the Confederate didn't eat, kids ate less. They only ate 2. Okay, drop down to neutral. Okay, when shown a neutral movie, Confederate ate, kids ate 4. Show a neutral movie, Confederate ate, kids still ate 4. Okay. So, what does that mean, and how do we know what it means? Well, a couple things. Typically, we start by looking at the marginal means. What's a marginal mean? It's a mean you calculate in the margin. So, here we've got for the movie clip emotional. So emotional movie clips. The scores across the other levels were 8 and 2. 8 plus 2 is 10. The mean, the average is 5. Right. So that gives us what's the effect of emotional movies. On average, kids ate 5. And then when watching neutral movies, on average, they ate 4. Okay. Looking now vertically, ignoring for a minute what movie they watched, just say whether the Confederate ate or not. When the Confederate ate, on average, about 6. When the Confederate didn't eat, on average, about 3. So we look at these marginal means to examine main effects. Okay. And so here I've put in 5 is equal to 4, which I know 5 is not technically equal to 4, but if I did statistical analysis on this, unless I had 1,000 subjects, more than likely 5 is not going to be statistically significantly different from 4. This number is too close together, right? So that means that if those numbers are really close together, that means an absence of a main effect. That means that there was not, we're going to go ahead and say, there was not a main effect of movie clip. Right? So if I'm interpreting these results, there wasn't a main effect of movie clip such that participants were equally likely to eat a similar amount when watching an emotional film versus when watching a neutral film. Okay. Now, if you look back at the data, you'd be like, well, but yeah, sorta. I mean, that's true, but not really, because whenever the Confederate ate, they ate way more for emotional. But then when the Confederate didn't eat it, they ate less. So yeah, it's different, and we'll come back to that in a minute with the interaction. So good eyes. Look down at the bottom. We got 6 is greater than 3. So I'm going to say that that's probably going to be statistically significant. So we didn't have a main effect movie clip, but there does appear to be a main effect of the Confederate modeling of that peer's behavior, whether they ate or didn't eat, such that when that peer ate, the kids seemed to eat more than when the peer didn't eat. But again, if you're paying attention, you're going to think, but not always. If it's a neutral movie clip, eating to not eating, that's the same. It's 4 and 4. Good. And that, hopefully now you're getting the idea that, yeah, well, there's these main effects, but they're qualified by a significant interaction. Something else is going on here. Right? And to figure that out, we have to look at the simple main effects. So the simple main effect is the effect of one factor on the dependent variable at only one level of the other factor. So we can look at one simple main effect here. For one level of movie clip, just the emotional movies, that's one level of that factor, right? At that one level, comparing the eating Confederate to the not eating Confederate. 8 is bigger than 2. Okay, that's a simple main effect. Okay. So now when we're trying to figure out patterns here, we're going to go, I typically like to start at the top left thing and go left to right, and then I'm going to go left to right again. I'm not going to go left to right, top to bottom. Doesn't make sense. Be consistent. So left to right, left to right. So the other simple main effect I look at here is, so when it was emotional film, Confederate ate, the kids ate way more than were not eating. But when it was a neutral film, they ate the same amount, whether the Confederate was eating or not, right? And so when you're looking for a significant interaction, you're looking for that sign, that mathematical function there to be different. So if we have a greater than on top and an equal sign, those are different. If we have a greater than and then a less than, those are different. And that's an easy kind of tell to say, oh yeah, this looks like there could be an interaction here. And ultimately, we typically leave it up to a statistical software package to tell us if an interaction is significant. But if you're having to kind of eyeball it, you can use this as your guide. One kind of exception to that, where the signs could be the same but it's still significant interaction, is if the difference, so the simple main effect, let's say we had greater than and greater than. If one of them is much more greater than, that could still be a significant interaction. So if our numbers were 10 and 1 on the top, and then 6 and 3 on the bottom, okay, well 10 is greater than 1 and 6 is greater than 3, but 10 is much bigger than 1 compared to 6 being bigger than 3. That would also drive the significant interaction. Okay, so that's one way to look at it. Take those out. We could also look at it, instead of going horizontally, we go vertically. So, okay, instead of looking at one level of movie clip, now we're going to look at one level of Confederate modeling, right? So when the Confederate ate, kids ate more when it was emotional than neutral. That's a simple main effect. Now we look at the other level of Confederate modeling. When Confederate wasn't eating, kids ate less when there was an emotional movie than when it was a neutral movie. So here again you see those mathematical symbols going in opposite directions, also indicating a significant interaction. Right? So we look at the pattern of simple main effects to interpret interactions, to see if they're there, and then also to make sense of them. So what's the story here? Right? Because when we're figuring out the story, we either go horizontally or we go vertically. We don't do both. If you try to do both, it gets overly complicated and jumbled, and you end up being redundant. Or if we try to go diagonally, that's screwy. Or if you go left to right, then top to bottom, also screwy. Either go left to right for both, or top to bottom for both. That's the only way to figure out what the story is. And both ways would be accurate, but one way seems to make more sense here as to what's going on. And to me, I'd say it's probably the horizontal story, right? Where the effect of the Confederate only happens if you showed them an emotional movie. Right? So it's an emotional movie. The Confederate eats. Kids tend to eat a good bit, nearly as much as the Confederate. Confederate doesn't eat; they don't eat hardly at all. Again, close to the Confederate. But if you show them a neutral movie, then kids eat about four peanuts, regardless of what the Confederate does. So maybe that 4 peanuts is the natural amount of snacking kids would do, right? But when you put them in this emotional setting, then that peer behavior, that peer modeling, is going to be attended to more readily. Make sense? Okay. Now, how to talk about it consistently, even when you get away from this example. One way to think about it here is if we think about using generic terms for the variables. So one factor being A, the other factor being B, with A having 2 levels, A1 and A2, B having 2 levels, B1 and B2. Then you can say, well, when A1, the dependent variable was blank, was high, was low, for B1 compared to 2. So when A1, watching an emotional clip, so that's our upper left quadrant. So we're calling movie clip A, Confederate behavior B. So when A1, start with emotional, when watching an emotional clip, participants' food intake, again, that's the dependent variable, was greater if the Confederate had a snack, B1, than if a Confederate did not have a snack, B2. Okay. Period. Never try to do these interpreting interaction with a single sentence. Always use 2 sentences. It's just much easier. You can do it with one, but I'm going to tell you right now, don't try. Much simpler. When these 2 things compare. Period. However, and there should always be a however if it's a significant interaction. because you're saying there was this relationship, but when I changed levels, something different happened. It went the other way, or it was equal instead of being greater than, whatever. Okay. So, however, when A2, so now I drop down to when neutral, the dependent variable, food intake, the amount of participants food ate when food eaten, watching a neutral clip, was the same whether the client had a snack, the Confederate had a snack, B1, or not, B2. Okay. So if you kind of can get that formula, for lack of a better term, into your head, you should be able to interpret any interaction you come across, at least any 2x2 interaction. And again, with more levels, it just gets slightly more complicated, but the same basic idea holds, where you start with one level and you talk about, at that level, here's these two little groups. Now I'm going to go to that other level of that same variable I started with. Here's these other two little groups. Okay. Now, it's important to be able to interpret the results when reading them and writing about them, especially for yourself. Another way to illustrate your results for people would be to graph them. So, example here, one approach would be to put, and this is an incomplete graph. It doesn't have everything labeled it should have, but it gives you the basic idea where on the bottom on the x-axis we have movie clip, right, either emotional or neutral, and then we've got these lines that have symbols on them, and there's a key for the symbols at the top where, okay, the yellow ovals means for Confederate behavior, Confederate was eating, and then the blue triangles, Confederate was not eating. So you can look at this graph pretty quickly and say, okay, yeah, I see when if they're showing an emotional clip, there's this big difference. When they're showing a neutral clip, no difference at all, right? And you can graph these same exact data, and it looks a little different. And all I did here was, instead of having the movie clip on the x-axis, I put the Confederate behavior on the x-axis, and then put the movie clip up in the key. And the graph looks a little different. So now you have, okay, well, when eating, there's this difference where emotional is higher than neutral, but when Confederate wasn't eating, neutral was higher than emotional. And again, which graph you're going to show, you wouldn't show both. Depends on which story you think makes the most sense. And again, to me, the first graph tells the story that makes the most sense. So you should be able to create your own graphs like this if given a table showing the results of a factorial study. And you should also be able to read graphs. Look at a graph and with just a little bit of guidance, be able to say if you think there are main effects or interactions. So look at this first one. We've got factors A and B. And one thing I tell you is, anytime the lines in these graphs of Factorial Designs intersect or look like they will soon intersect, so if you continue that line off into space and it's going to intersect pretty soon, that's an interaction. If the lines are parallel, there's no interaction. Okay, and that's a quick read. See, oh yeah, they're going to intersect. That's interaction. That's the easy part. So in this first graph, clearly an interaction between A and B. Something different is going on when these two variables get together. And then in terms of interpreting the main effect, that's a little trickier. The easier one to look at is always the one, to me anyway, the variable, the factor whose levels are identified by the key. So in this case, the factor of A. So you figure out if there's a main effect by finding the midpoint of the line of A1. Okay, so imagine that a dot in the middle of that line, and then look at that line. So that's the yellow circle line. So then now look at the A2 line, which is the blue triangle line, and look at the midpoint of that line. Now, if there's vertical distance between those 2 points, the bigger the distance, the more likely there is a main effect. Okay. So if there's no difference between those distance between those points, no main effect of that variable. So this one looks like, yeah, there probably is. Looks like A1, whatever our dependent variable is, A1 caused more of it than A2. Okay. Now for the B's, it's a little trickier. So for the B's, instead of finding this point on a line, now you have to do a little more mental visualization. So for B1, you look above it and you see the yellow circle, you see the blue triangle, and you imagine a point in the middle of those two symbols, equidistant from each symbol. And you look over at B2 and you say, okay, is there what's the point there that's equidistant between those two things? And then you think, okay, I've got those 2 points in my mind. Is one higher than the other? If those 2 points are even, there's no main effect. If one point's higher than the other, then there is a main effect. And looking at this one, I didn't draw it super straight, but it looks to me like probably not much of a main effect of B. This looks like the middle points for those two things would be about even. One wouldn't be much higher than the other. So we've got a main effect of A, no main effect of B. However, the main effect of A is qualified by a significant A by B interaction. And then you would interpret the interaction. Okay. This one is one that's fully crossed, so it's clearly an interaction. And then we say, okay, well, look at the midpoint of the A1 line, the midpoint of the A2 line, they're about where those two lines intersect. So those 2 points, one's not higher than the other, so A is not does not have a main effect. A1 is not higher than A2. A2 isn't higher than A1. So no main effect of A. Okay, now we look for B1. What's that middle point? For B2, what's the middle point? And again, when something's fully crossed, you're going to have no main effect of B either. So no main effect of A, no main effect of B. However, there was a significant A by B interaction. Okay. Third one. Again, we have looking at main effects first. That A1 line is higher than the A2 line. That midpoint is higher than the other midpoint. So we've got a main effect of A. And then we look at for B1, the point between the two symbols down near the bottom. For B2, point between those symbols a bit higher up. So it's like, yeah, probably a main effect of B as well. So a main effect of A main effect of B, but no interaction. Right? Those lines are parallel. They don't look like they're going to cross anytime soon. So 2 main effects and no significant interaction. Okay. In this one, A1 and A2 certainly closer together than the previous one. And I'd say in this one they're probably close enough together, because I tried to make them look that way, that I would say no main effect of A. And if they were exactly the same, those lines would really almost overlap, right? So no main effect of A. And our B is gone. But if we look at B1, right, the point between the two symbols down at the bottom, B2, it's up higher, but there does appear to be a main effect of B, but again, still no interaction because we don't have those things intersecting. Okay. So you should be able to look at a graph, I expect you to, for a 2x2 factorial design, and tell me if there's a main effect, how many main effects there are, and whether or not the interaction is likely to be significant. Okay. All right. Summing up, factorial designs very common whenever you want to look at group differences. Right. So a lot of experimental designs are going to use a factorial design, just because if you're going to go to all the trouble of conducting an experiment, this therapy versus this therapy, you're going to add something else, some other factor while you're at it, just because it doesn't make sense not to. But again, factorial designs aren't limited to experimental designs. If you're using a subject variable, gender, ethnicity, age, whatever, then it's no longer experimental, but it could still be factorial if you have more than one way you could create groups within your study. Okay. When you're interpreting these things, you're looking at main effects, right? Which, however many factors you have, that's the number of potential main effects you have, and then also potentially significant interactions between those factors, and significant interactions qualify any significant main effects. Often when you design a factorial study, you're primarily interested in the interaction term. Like, well, okay, I'm looking at these variables. There may be a main effect of this, and maybe one of this, but I don't really care. What I care about is I think there's going to be an interaction between these two variables, such that the effect of one variable will be different depending on the level of the other variable. And the last thing, be sure you are comfortable with, capable of reading the graphs of Factorial Designs to be able to interpret main effects and interactions. Okay, that's all for now. Take care.